Hello class, good to see you. I can tell you are ready to learn. Today we'll be reviewing multiplication and how to represent it using repeated addition, equal size groups, arrays, area models, equal jumps on a number line, and skip counting. To do that, we need to remember the important vocabulary that involves multiplication, like factors, product, multiplication symbol, rows, columns, arrays, equation, and equal groups. For example, let's look at these three boxes. These three boxes go across, they are horizontal, so are going to be representing rows. In this case, we have 3 rows. Now let's put some stuff inside. Now when we have this picture here, it's going to represent a multiplication, and it's telling us that each row has 4 objects. Now this is going to equal, if we add 4 plus 4, we're going to have 8, then plus another 4, we're going to have 12, so the total of this multiplication is going to be 12. Now the factors are going to be 3 and 4. When we multiply them, we're going to read it like this. 3 times 4 equals 12. Or many times we substitute the times for groups of. So the multiplication can read like this too. 3 groups of 4 equals 12. Now 12 is going to be the product. So the product is the answer to the multiplication. We can look at the same problem with different eyes or in a different point of view. This time we have 4 columns. Now columns go from top to bottom. We're going to drop the same number of objects before, and we're going to make sure each column has the same number of things. In this case, we're going to have 4 columns times 3 objects each is going to equal, if we count little by little, 3 plus 3, 6, plus 3, 9, plus 3, 12, and that equals 12. We have the same. We have factors, which are going to be 4 and 3. We can read this multiplication as 4 times 3 equals 12, or the times symbol can be read as groups of. So we can tell now 4 times 3 equals 12. And 12 is still the product or the answer to our multiplication. Let's see different ways to represent the multiplication. For example, if we use the algorithm, it's basically multiplying 4 times 3 equals 12. But we can solve the same problem using repeated addition, which is 3 plus 3, 6, plus 3, 9, plus 3, 12. So my answer is going to be 12 again. I can skip count by 3s, 3, 6, 9, and 12, and my answer is going to be the same. I can do our model, where we don't know the whole, but we know that each part is 3, and 3, and 3, and 3. At the end, all of them together are going to give me the 12. I can do equal groups, putting 3 things inside each group. And when you add them together, the answer is going to be 12. You can use skip counting in a number line, which is basically the same as skip counting by 3s. We can have the area model. Now, for this one, don't forget to number the rows. So 4 times the number of columns, which is 3 columns. And the answer is going to be 12 again. Or we can use the array model, where it's going to represent the same numbers. 4 rows times 3 columns equals 12. Now, let's see how we can apply these different strategies to solve the next problem. The first step to solve a problem is to read it. So let's do it. Osvaldo built 5 pyramids using his magnetic set. If each pyramid was built with 4 triangular pieces, how many pieces does he have in all? Now the second step is to underline the question so we can focus on what we need to do. How many pieces does he have in all? Now, the second reading I'm going to do is to find the information I need to answer the question of how many pieces does he have in all. So Osvaldo built 5 pyramids. This is important to know, 5 pyramids. using his magnetic set. If each pyramid was built with 4 triangular pieces, so this is telling me that each pyramid has 4 triangular pieces. Now, using this information, I'm going to answer the question and I'm going to leave a blank because I don't know yet what's the answer. So I'm going to take away the how, the many, and the auxiliary verb does. Now I have left pieces, he having all. And that means I have to use those words to make a new sentence. He is going to be Osvaldo. So instead of saying he, I'm going to write Osvaldo. So let me write the answer statement here at the bottom. Osvaldo has blank pieces in all. So has blank, and then I'm going to use pieces in all. Pieces in all. I have my answer statement and I'm going to be working on the problem. Now the first thing I know is that he's building pyramids. So I have an example here. So this is one of the pyramids he has, but he has 5 of them. So I'm going to put them here so we can study the pieces here. Now it says that each of them has 4 pieces. So let's see one. Let's open one to see if it has 4 pieces. And yes, that's 1, 2, 3, 4 pieces. So I can assume this one has 4 pieces. This one has 4. The third one has 4. The fourth one has 4. And the fifth one has 4. So yes, all of them have 4 pieces each. Now let's work it out in a mathematical way. So the first thing I know is that he has 5 pyramids. That each has 4 triangular pieces. So the first thing I'm going to do is a little representation of the problem. And for this one, I'm going to use a bar model. So our model represents the whole, which in this case, I don't know what the whole is. So I'm going to put there a question mark because I don't know how many he has in all. That's my question. But I know he has 5 pyramids. So I'm going to cut this into 5 pieces. Each piece is going to represent 1 pyramid. So pyramid 1, pyramid 2, pyramid 3, pyramid 4, and pyramid 5. But I know that each one has 4 pieces inside. So I'm going to do one of the strategies we studied before, which is going to be keep counting. This one has 4, and this one has another 4. So 4 and 4 is going to make 8. This pyramid has 4 more pieces, so that's going to be 12. The 4th pyramid is going to have another 4 pieces, that's going to become 16. And the last pyramid is going to have another 4 pieces, that's going to become 20 pieces. So now I have my answer. My question mark is going to equal 20. Now to make sure, I'm going to use this representation to solve it using an algorithm. So I know he has 5 pyramids, and I know that each pyramid has 4 triangular pieces. So this is going to be represented by a multiplication, and I know that 4 times 5 or 5 times 4 equals 20. Now usually I like to just make sure I did a good job by using my fact family, which is the same. 4 times 5 is going to equal 20. Now in this way, I represented my problem in 3 different ways. Now if I count my pieces, I can prove that I have the 20 in all. So let's just check. First pyramid has 4, right? We had this pyramid 4. Let me pile them up together, 4. The second pyramid has another 4, which is going to make 8 pieces. The third pyramid has 4 again. The fourth pyramid has 4. And the last pyramid has 4 again, or 2. All together make 20 pieces. Well guys, this is all for today. I'm hoping this was a useful lesson for you. Can't wait to see you next time. Bye!